اللهم لا سهل إلا ما جعلته سهلا، وأنت تجعل الحزن إذا شئت سهلا. اللهم يا معلم إبراهيم علمني، ويا مفهم سليمان فهمني. اللهم علمني ما ينفعني، وانفعني بما علمتني، وزدني علما.
كالغيث كن أملا وجد من دون مقياس، سقيا الجمال تبثها لتطيب أنفاس. عظم قلوب الناس أن الناس للناس، كالغيث كن سببا لتحيي قلب إنسان. جد بالذي تحسنه مهما كان مهما كان. أوليس يجزى محسن إلا بإحسان. قلبي اطمأن فكلنا كالغيث للغير، ما زالت الدنيا بخير.
my two pendulums, but they have different lengths. The wooden pendulum has a longer string, the styrofoam pendulum has a shorter string. So the theory states that the shorter string pendulum should have a shorter period of oscillation, or in other words, it should swing faster. So let's do an experiment to see if that's true. Release them, same time. And you should notice that the styrofoam ball, the shorter pendulum, is swinging faster, has a shorter period of oscillation than the longer string pendulum. So it seems that that theory holds true as well. Components of gravitational acceleration acting on the pendulum bob. Here's my pendulum bob deflected at some angle theta from the vertical. Now the bob is being acted upon by gravity, so it's a downward force which is equal to the weight, which is equal to the mass times the acceleration due to gravity. Now, relying on some basic geometry, we see that the theta angle shows up here on the bob. Now also recall some basic trigonometry, and when we do that, we can break down the forces in the direction parallel to the string and perpendicular to the string. First of all, we have the force is equal to mg cosine theta for the gravitational force parallel to the pendulum string. And we have force equal to mg sine theta for the force that's perpendicular to the pendulum string. Now it's this perpendicular force that accelerates and decelerates the pendulum bob as it swings. let's go ahead and show that. I'll have a small release angle for the wooden bob and a larger release angle for the styrofoam bob. And they get back to my hands at the same time. Again, so it's independent of the release angle of the pendulum. Now, why is that? Well, the higher pendulum accelerates for a longer period and picks up a higher velocity, so it covers that distance in the same amount of time as a shorter swing for the wooden pendulum. Now let's take a look at this from a side view. I'm going to start both pendulums from different angles, and we should see them swing back through the vertical at the same time. Let's try that again. Now, here are my two pendulums. I have one with a wooden bob, which is relatively heavy, and one with a styrofoam bob, which is relatively light. Now I've set the string lengths so that they're equal. So that means the center of gravity of both bobs are the same distance from the pivot point of the string here at the top. Now, as I showed earlier, the physics says these should both have the same period of oscillation since the pendulum length is the same, regardless of the weight of the pendulum bobs. So let's do a quick experiment to see if that's true. Let them both go. And for the first couple swings, they do stay in